Hello, I'm Charles Elashi, and it's my pleasure to welcome you to the Jet Propulsion Laboratory. Of all the places in the world, I believe JPL is the single best place to visit if you want to learn about robotic exploration of space. The lab got its start when a group of rocket enthusiasts and students at Caltech undertook a series of rocket experiments.
That was 1936. By the 50s, we were building rockets like these. Then, in 1958, in answer to the Soviet Sputnik, JPL built and helped launch the first U.S. satellite, Explorer 1.
Since that time, JPL has been our nation's premier center for the robotic exploration of our solar system.
We also operate the Deep Space Network, the vital communications link that allows us to send commands to and receive data from an armada of spacecraft.
Not a day goes by that JPL isn't involved in some new discovery, and we share that information with the public and our schools.
It's a privilege to conduct space exploration on behalf of our nation. We hope you come away understanding how the passion of our employees and their spirit of exploration motivates everything we do. We thank you for coming, and we hope you enjoy your stay.
We have always looked up at the night sky and wondered, what is out there? How did it all come to be? And the most fundamental of all questions, is there life elsewhere, or are we alone? Answering these questions requires a journey to the planets and beyond. Our solar system coalesced out of a cosmic dust cloud some 4.5 billion years ago. Most of the dust condensed into the sun, which ignited into a nuclear furnace and burst into life as a star. The sun's internal fires provide the energy for almost every living process on Earth. Now we are exploring other places in our solar system where life might exist. Our search begins with Mercury, the planet closest to the Sun.
4 billion years ago, the planet Mercury was struck by a 62-mile-wide asteroid, and it created a crater the size of Texas. That's just one example of the kind of violence that happened all the time when our solar system was forming. The next planet out from the Sun is Venus, which has long been difficult for us to understand because of its very heavy atmosphere.
In the early 1990s, a JPL spacecraft used radar to penetrate the clouds of Venus. The result was a global three-dimensional map that revealed the surface of this hellish world, a place where even lead melts. No one expects to find life as we know it on Venus. Straight ahead is another planet. As this blue world comes into view, it is apparent that this is an entirely different kind of place. Our world enjoys an abundance of water, the great elixir of life. Making discoveries about our own planet from the vantage of space is one of JPL's proudest achievements.
For decades, JPL has been observing the mysteries of Earth from space. We study the atmosphere, looking at clouds and hurricanes. We assess changes in sea level and sea surface salinity, and look at phenomena such as El Niño and La Niña. We're developing instruments to assess small changes in Earth's topography to enable more accurate predictions of earthquakes and volcanoes.
JPL missions are also measuring the melting of ice sheets at the polar caps and atmospheric changes, including the vital ozone layer, so important to protecting life on Earth.
There are many Earth-observing missions on the horizon, and you'll soon be hearing much more about them. Some of these missions will measure sea level and wind patterns over the ocean. Another mission will measure the amount of carbon dioxide in the atmosphere. With more cases of drought occurring in the world, measuring soil moisture across the globe will be of key interest everywhere. Taken together, all of these missions are critical to better understanding the changes our planet is undergoing.
Of all the other places in our solar system where life might exist, Mars may be the best bet. Yet the red planet is a world of extremes compared with our own. This is Olympus Mons, an ancient volcano as large as the state of Arizona. It rises 16 miles high. That's 3 times higher than Mount Everest. This gigantic scar is called Valles Marineris. Imagine the Grand Canyon stretching from coast to coast across North America, and you can begin to appreciate the scale of this massive trench. Though there are no signs of little green men here, primitive life forms could have once, or might still, exist on Mars.
That's one major reason why, since 1997, we have been operating spacecraft at Mars 24/7, 365 days a year. From orbit, Mars seems to be telling us that in the past it was a much warmer and wetter place, wet enough that it possibly could have been water carving these channels that we see in the surface.
We know that wherever on Earth we find water, we find life. Might the same be true on Mars? That's why there's such an emphasis on finding Martian H2O.
We know there's water underneath the surface of Mars. Our spacecraft orbiting the planet have told us that. But to really understand the story and tale of that water, you have to get down there, move about, and explore. Sojourner was the first to do this back in 1997. But Sojourner was small, about the size of a microwave oven. Then came Spirit and Opportunity. They were about the size of a golf cart. But now there's Curiosity. It's the size of a car. It's so big that engineers at JPL had to invent a brand new way of getting to the surface. A way that some people, even engineers, thought was crazy. We weren't 100% sure it would work. It made for a very tense and dramatic landing that I will never forget.
Switch, things are looking good. Coming up on entry. It is reporting that we are seeing G's on the order of 11 to 12 Earth G's. Bank reversal 2 is starting. Parachute is deployed. Heat shield has separated, we found the ground. Standing by for backshell separation. We are in powered flight. Standing by for sky crane. Sky crane is started. Touchdown confirmed. We're safe on Mars.
Thumbnails are complete. Got thumbnails. wheel.
We're on wheels down on Mars.
Almost right away, Curiosity made a discovery that surprised and delighted scientists. A bed of rocks containing smooth pebbles. That means there's clear evidence that we were in what used to be a flowing stream on Mars. A few months later, the rover made an even more exciting discovery. The first sample ever, drilled from inside a rock on Mars, revealed an ancient wet environment with the right ingredients that could have sustained microorganisms. And who knows what other exciting discoveries await? As for the big question, is there life, or has there ever been life on Mars? Well, that's a question for future missions.
Mars is the last of the rocky planets as we journey further out into the solar system. Next, there's a gap where a planet might be expected to be. Instead, there's a vast swarm of rocks called the asteroid belt. A team of JPLers is constantly scanning the skies to track the potential threat of a wayward asteroid hitting our planet.
February 15th, 2013 was an extraordinary day for anyone interested in asteroids. On that day, a 130-foot asteroid passed within 17,200 miles of the Earth. That's the closest approach ever on record for an object of that size. Coincidentally, on that same day, a smaller asteroid did enter the atmosphere over Russia, exploded several miles in the sky, causing a brilliant fireball. It was the largest known asteroid to hit the Earth in over a century. This was a very vivid example of why it is so important to know more about these interesting objects. Meanwhile, out in the asteroid belt, a JPL spacecraft called Dawn is in the midst of its mission to explore two massive asteroids called Vesta and Ceres. They're sometimes referred to as protoplanets. What kept them from getting bigger was the influence of Jupiter.
The largest of all the planets in our solar system, Jupiter could hold 1,000 Earths. Like the Sun, it's a giant ball of mostly hydrogen gas with no solid surface. For 8 years, Jupiter had a visitor, a JPL spacecraft called Galileo. This orbiter explored not only Jupiter, but also the giant planet's 60-plus moons, each a fascinating world.
And now a new mission called Juno is on its way to Jupiter. Its purpose is to learn more about the origin of the planet. We don't really know everything about what lies beneath those beautiful swirling clouds. Is there a solid core? And if so, what size is it? Juno will tell us more not only about Jupiter, but should also yield clues about the origins of the entire solar system. Juno arrives at Jupiter in 2016. As it nears the planet, it'll be accelerating to a speed of 160,000 miles per hour. That will make it one of the fastest human-made objects in history.
Next comes the solar system's majestic gem, Saturn, the most serenely beautiful of all the planets. Saturn's rings are made of ice and rock particles, some as small as dust, others as large as a house. In 2004, Saturn welcomed its first orbiting visitor, the JPL-built Cassini spacecraft. While Saturn and its rings have been bewitching to gaze upon, the biggest surprises have so far come from the Saturnian system of moons. Phoebe was the first moon Cassini trained its cameras upon. This was the best image we had of this moon before Cassini. This is Cassini's image. If you want to know what our planet was like when life first appeared, Titan may provide answers. Scientists believe that Titan's atmosphere resembles that of the primordial Earth. Cassini is now mapping Titan with its powerful radar. But it is Enceladus that has astonished scientists. This moon appears to have rolled over on its side. One result is that at the South Pole, where it should be the coldest, there seems to be an unknown heat source that is gushing up water like a Yellowstone geyser. Dubbed Cold Faithful, scientists were amazed to find evidence of water so far away from the sun. The number of places in the solar system suitable for life may be much larger than ever before imagined. Next, we catch sight of Uranus. While Earth is blue because of its water, this planet's color comes from an abundance of the gas methane. Uranus has had only one visitor, Voyager 2. After Uranus comes the planet Neptune, also visited by Voyager. Voyager 1 and 2 are now headed toward interstellar space. The vastness of space is almost unimaginable. The physical distances seem insurmountable. Even today, we have barely crossed the threshold into the larger universe that is all around us. But we can know about these distant places through telescopes. And from the vantage of space, we can behold glorious sights.
JPL's been a major contributor to a fleet of space telescopes. Using them and other techniques, astronomers have discovered almost 1,000 planets orbiting other stars now. Most of these planets are giant Jupiter-sized things, so the next big quest is to find an Earth-like planet orbiting another sun. By studying its chemical composition, we may be able to detect signs of life if it exists on a distant planet. If that happens, our understanding of our place in the universe will be profoundly changed.
The more we know, the more questions we have. And the ancient questions remain. What is out there? How did it all come to be? What will be our fate? But this much we can say. Every atom in your body was once inside a star. So the next time you look up into the night sky, remember, you are, quite literally, stardust. You and your dreams belong to the stars, and they to you.